Well, hello, Internet, and welcome to my Thursday live stream. I normally do this on Wednesday, but yesterday I had to go to the doctor, and, things like that happened. But thank you for everybody that is joining me. Today I am going to cover trigonometry in one video. Last week I covered algebra in one video. And this is mainly focused on people that want to understand calculus. So what I'll do is I'll mainly focus in on the hard parts of trigonometry, but I'm going to cover pretty much everything. And the way I'm going to teach is I am going to just solve a ton of problems and explain everything, the rules, and everything you need to memorize. And at the end of this video, I will post all of my notes 100% for free. So you'll basically get like a little cheat sheet on trigonometry also. And also, I just uploaded my video on YouTube about polyphasic sleep and how I train myself to sleep 3 hours a day. And so there might be some questions about that. And if you have any questions about polyphasic sleep, which is what it's called, I just realized I cut myself when I shaved. That's not a good thing to do. I apologize. I have to drink a lot while I do this video. Otherwise, I will lose my voice because I have lost my voice. So let's see what is up. I'm just going to jump in here, and if there's any questions that anybody has along the way, feel free to post them. This is what I do. I just solve all these problems and, move on from there. I'm also going to cover one thing that I did not cover in my Learn Algebra in one video, which is conic sections. So that's what I'm going to cover first, and then I will get into trigonometry afterwards. So let's just start. So what exactly is a conic section? Well, you can see sort of examples of them here. Basically, it is a slice that goes through a cone. All right? And we are able to graph all of these on the coordinate plane. And I'm just going to come in here and just draw some examples. So we can have circles, of course. And let's see, there it is. There is a circle. We are also going to be able to draw ellipses. So here is an example of an ellipse, sorta. And we're also going to be able to draw parabolas. So let's just come in and draw a parabola. Let's see if that, hey, look at that. And we're also going to be able to draw hyperbolas. So let's pick another color here, and this would be sort of an example of a hyperbola. So if we just draw, it's going to be like two parabolas that are going to be divided apart from each other, and I do my best to keep everything working here as best as humanly possible. So there you go. There is a hyperbola. All right. And let's move on. So I'm just going to do conic sections here really quickly because I didn't cover them in the Learn Algebra video, and that's what I want to do. So we're going to start off with circles, and if you're here because you have questions about polyphasic sleep, just ask them. I'll be more than happy to answer any of the questions I have. Okay, so with a circle, what we're going to do here is, let's say you were told that you're going to have a center at 2, 4. Okay, so you're going to want to go over here and graph that out. So we're going to go over 2 and up 4. And if at any point in time I have a typo or something like that, feel free to say, hey, you messed that up. Like last time I did the algebra 1 video, I think I only had 2 typos. One time I meant to write a 8 and I wrote a 6. Whatever. Things like that happen. These videos are normally really long. Okay, so now that we have that, I'm going to get another color. We have a center at 2, 4, and we plotted it out here on our coordinate plane. So what we would like to do is be able to find our diameter. And you can see here an example of the formula that we can use to figure that out. So I'm just going to redraw this. So I'm going to take these points here. I'm going to take the x point, and I'm going to say 7 minus, and this is -3. And then what we're going to do is square those values. I guess I should throw another parentheses in here just to not cause confusion here. And then we're going to have plus and 4 minus 4, which is also going to be squared. And let's move this out here a little bit so that I can fit that in there. Good enough. And then we're going to have to get the square root of that. All right. Well, I'm just trying different things to see what works the best. I like the idea of doing live streams because then people can ask questions. And also, this is going to be recorded and it's going to be placed on YouTube after it's done. So we get best of both worlds. All right. So if we go and get these calculations, what we're going to end up doing is having 10 squared plus 0, and we'll get the square root of that, which is ultimately going, those cancel out, and you're going to get a value of 10. All right, now if we would like to have the radius, of course, we would just, the radius would just be half of the diameter, so that means our radius is going to be 5. And then we can easily just come in here and plot those values. So 1, 2, 3, 4, 5. And 1, 2, whoops, didn't mean to do that. 1, 2, 3, 4, 5. And up here, and 1, 2, 3, 4, 5. And the way that, reason we're studying conic sections like this is because we want to be able to look at ideas and formulas and such and be able to draw them really quickly. So, and that is really what is the point here, is to recognize a formula and then to be able to go right in and just draw that shape on the coordinate plane. So it works really, really simple. Would I ever consider doing C# videos? I have a ton of them on my YouTube channel right now. So, you know, they're available there, and C# hasn't changed since I made those videos, so everything should work out fine. I also made a Unity video tutorial. If you want me to, I just ask and I'll post it into the little chat box area, and you can see that. I made like 35 videos on making video games in Unity. Okay, so that is how we can go and make a circle. This is right here basically going to be the way that we would represent a circle in a formula. And in this circumstance, what we were saying here is that our circle is going to be centered at the point of H and K. So if we see a formula of this form, we know that that is where our center is going to be. And then we are going to have our radius down here, okay? So really, really simple to figure out how to graph these circles. And I'll just go and plug this in here. So what we have is, if a circle center is at 1, 2, and it has a point at 5, 2, what would be our radius in that circumstance? Well, again, we're just going to do the same type of stuff. So I'm going to go, let's make that look a little bit more like a 5. So we can have 5 minus 1 squared and plus 2 minus 2 squared. And then we're going to get the square root of this right here. We can put that in there. And this is going to end up being equal to the square root of 4 squared, which is going to be equal to 4. Yes, I am streaming. Glad you're happy about it. Okay, so now all we need to do is go and plug our center coordinates and the radius into the formula. So let's just do that. So we can come in like this, and our formula is x minus h squared plus y minus k squared equal to r squared. And we'll be able to plug our values in here. X minus 1 squared plus y minus 2 squared, which is going to be equal to 4 squared. And we can then go and plot this directly onto our coordinate plane. So once again, we're going to have a point at 1, 2, just as it said. So 1, 2, like that. Our radius is 4, 1, 2, 3, 4, like that. And 1, 2, 3, and there, and let's see if I can draw a circle that looks like a circle. Okay, and there we are. And, you know, good effort with the software that I'm working with here right now. All right, I know this is called trigonometry, but in my Teach Algebra in one video, I didn't cover conic sections, and so I wanted to cover them really quickly. Parabolas. So again, this is all about looking at a formula and very quickly figuring out how to draw that onto the coordinate plane. So the standard form for a parabola is exactly as you would see right here. So this is our standard form for our parabola. And in this circumstance, H is going to represent the horizontal position, and K is going to represent our vertical. So let's say I wanted to solve the plot y is equal to x squared minus 2x plus 5. And yes, you do need to understand algebra. That's why I made algebra first, to be able to solve these problems. So if you're rusty on algebra, then I have that video. So there you go. So what we want to do here is we want to put it in a standard form so that we'll be able to calculate what is called the focus. And I will explain what the focus is and the directrix and all these fancy things as we continue. So here we go. We got this guy, and let's go and put it into our standard form. What we want to do is to complete the square. So what we're going to do is we're going to take a 1 from the 5. But you may say to yourself, what does it mean to complete the square? Well, this is an example of completing the square. So this would be x minus 1 and x minus 1, like that. This is, of course, going to be equal to x squared and minus 2x plus 1. I have to always look around to make sure that I am drawing on the board and it's showing up here. Okay, so how did we take this guy right here and convert it into that guy right there? Well, we used a procedure called completing the square, and this is basically what you do. You go x squared, and you just break the center part into 2 additional parts, exactly like that. And I'm going to do that here for this example. All right, so what am I going to do? I'm going to say y is equal to x squared minus 2x plus 1 plus 4. Okay, see, I can do that completion of the square now with that because I broke the 4 off of it. All right, so what I can convert this into now is exactly the standard form. So I'm going to say x minus 1 squared, minus 1 squared plus 4. And there we have it in our final form. Thank you for following there, Mopey. I appreciate it. Okay, so what we can do also is we're going to be able to use another formula. So let's just do this. We can say something like use a squared minus 2ab plus b squared. And this would be equal to a minus b squared to factor that expression. All right, where's my next one at here? Working off of slides. I'm using GoodNotes here to basically draw everything. Okay, so what do we want to do here? I said that I was going to explain exactly the directrix and the focus and all of those different things. Okay, so what I'm going to do is, because I know, let's get this out of the way because I'm going to have to write some other different stuff here. So let's just erase this out of here. There we are. Okay, and get a different pen color. Okay, so we know here that the vertex of the parabola is going to be at 1, 4. So what we can do is just go 1 and 4. Exactly. Well, let's use a different pen color. This is going to be the vertex of our parabola. or the very bottom of the parabola? Well, we're going to have a basically what we're going to do is, if you understand how conic sections work in this situation, is that we are going to put that in there, and then basically we are just going to graph from that point as if it is the 0, 0 point on the coordinate plane. The y is equal to x squared. So what you're going to do is act as if 1, 4 is 0, 0, and then solve for y squared. So it works out pretty simple. So let's go, and I'll actually do this. I'm going to say if x, and let's go draw a line in here like this, and let's have our x terms be the value of -1 and 0 and 2 and 3. Okay, draw this in here, and then I'll just sort of show you how this would work out. So what you're going to do for your y term is you'll have -1 minus 1 squared and plus 4. So I'm taking this guy right here and utilizing it to get all my different values. So we're going to have a point at 8, and we continue on. So I'm just making adjustments, acting as if that 1, 4 point is actually the 0, 0 point on our coordinate plane. So I'll say 4, and this is going to give us a value of 5. And I think you get the point here. For our other two values, we're going to get 5 and again 8. So what we're going to be able to do now is to go and actually plot these out onto the screen. Well, no, you don't need to, what we did there is our goal was to get this guy right here, so this formula that we have right here, and to be able to complete the square. And the only way to be able to do that is to give this a value of 1. So that's the reason why we changed the 5 into 1 and 4. 1 and 4. And then that gave us x squared minus 2x plus 1. And x squared minus 2x plus 1 is exactly the same as this, if our goal is to get this form that you have up here. Okay? Hopefully that wasn't confusing at all. So there we are. And that is the reason why we changed a 5 into 1 and 4 so that we could complete the square in that situation. All right. So now what we need to do is just plot all of these points. So if x is equal to -1, we know we're going to have a value of 8. And if x is equal to 0, we know that we're going to have a value of 5. And again, we're going to, if x is equal to 2, we're going to have a value of 5. And then if x is equal to 3, we will have a value of 8. And I'll get into now exactly what the directrix is. Now, the directrix is going to be, well, basically, yeah, the directrix is just going to be this line that goes right through here. Okay? So there is our directrix, and then, of course, we're going to be able to draw in roughly the way the parabola is going to work for us. And that is the whole entire point of it. And the other point that is of interest is what we call the focus. And it is the point about which the rays from the curve are going to converge. And since we have the form that we were working with here, what we're going to be able to do is find that the focus is going to be, so the focus is going to be at H, and then plus, or it's going to be at H, and it is going to be, if I can get rid of that little dot right there, H and K plus 1 over 4A, like that. And then what we're going to be able to do is plug in the K value. Remember, you can see the K value right there, the H value right there. I'm just putting them into this form so that I can then pull them back out and find all these individual points. All right, so our focus in this situation is going to end up being, what is h? Well, h has a value of 1, as you can see right there. And then k is going to have a value of 4, as you can see right there. And then we just need to add on 1/4. A does not have a value because there's no value right there. And that is going to then give us a point for our focus of 1 and 4 1/4. And that is where the focus goes. Let's see if I can pick another color here that can be seen. So roughly 1 and 4 1/4. So the focus is going to be right there at that red point, while our directrix is going to be this line that lines underneath of it. So directrix, just so you know how to spell it. Okay? All right, I have to get a drink. Okay, so now let's move on to our other different points. Another thing is we're also going to have, if you want all the jargon, we have another thing called the axis of symmetry. And it's just a line that divides the parabola in half. So this would be the axis of symmetry right there. All right, and that is all the jargon in regards to working with parabolas. Let me give you another example here because it might make a little bit more sense. All right, so what we want to do here is we want to write this parabola in standard form. So there is our standard form. How are we going to do it? Well, we're just going to come in and I'm going to say y is going to be plus 3. We'll get that on that side of the value. The axis of symmetry, be a diagonal. Yes, parabolas are going to be able to go in any direction. I'll cover that. When do I cover that? I cover that soon. Yes, you're going to be able to have a parabola go like this, like this, like this, or like this. And I'll cover that here in a couple slides. All right, so we're going to have then 4x squared minus 16x. And all I'm trying to do is to put this guy right here into this form so that I'll be able to easily graph it. All right, so I'm then going to divide, remove the coefficient from x squared, which means this is our coefficient. We covered that in the last video. And if I do that, this is going to be y over 4 plus 3/4 plus 4, which is going to be equal to x squared minus 4x plus 4. Exactly like that. And then what we'll be able to do is create a trinomial by taking 1/2 the x coefficient and square it and add this to both sides. And we also need to complete the square with this guy right here. So this is going to remain y over 4 plus 3 over 4 plus 4. And if we complete the square, this is going to end up being equal to x minus 2 squared. And I cover more about completing the square in the algebra video. Then what we need to do is multiply both sides by 4 to eliminate any of the fractions that we have here. And if we do that, we get y plus 3 plus 16 is going to be equal to 4x minus 2. And I think you can see that it's starting to slowly but surely get to the point where it's the form that we're trying to get. Further simplify this. I'm taking my time with this just to make sure that everything is 100% understandable. X minus 2 squared, and then we just subtract 19, and boom, guess what? We have our formula in the standard parabola format that we're looking for by subtracting 19 from that. Okay, and from looking at this, again, I'm going to be looking at A, H, and K here to make these predictions. So we know that A is going to be equal to 4, because it says that's what it's equal to. H is going to be equal to 2, and K is going to be equal to negative 19. So that means our focus is going to be equal to H and K. which is 2 and negative 19. And basically, I'm just going to put a point at 2 and negative 19, which is going to be 2 and negative 19. It's going to be down here. There is our point. And then I am going to graph in this circumstance, y is equal to 4x squared. So x, whoops, go away, Siri. Siri's talking to me. Go away.
I'm not sure I understand.
Oh, go away. All right, Siri was talking to me there for a minute. And then I said her name again.
Interesting question.
Okay. I have to make sure I don't say anything that's near that word, otherwise the iPad starts getting crazy. Okay, so if we have let's do this in a different color. So if we have, in this situation, x, and this is going to be 3, which is 1, based off of our shenanigans we're pulling here. 4, which is actually 2. Then we will have a value for y. Y is going to be 4 times 1 squared, which is going to be equal to 4 minus 19, which is equal to negative 15. Good Lord, what is going on here? Oh, thing got messed up. I accidentally hit something. Apologize for that. Jeez, oh man. All right, let me get back to this. There we are. Maybe I should take the keyboard off the bottom of this. All right, and in the circumstance in which we have a 4 for our x term, what this is going to end up being equal to is 4, 2 squared, equal to 16, of course, minus 19, which is going to give us a value of negative 3. So we're going to have points at, is this still going to fit on the board? Yes, it is. 1 and negative 15, and another point at 0 and negative 3. So we can come in and graph this. So if we have 1 and negative 15, we're going to have a point right here, and 0, and that would end up being equal to negative 3. 1, 2, 3, like that. And roughly we're going to have a parabola that is going to look roughly like that. So the whole idea here is just to be able, yeah, Siri loves talking to me. Oops, I said it again. She didn't hear me that time. That's a good thing. All right, so let's move on to another problem here. What would we do? I have to get another drink. What would we do if we were told the focus and the directrix? I already explained exactly what the directrix was. Let's go and get this guy. So this is the question that you had asked before. Kanan, I think is your name. Basically, what we need to know is we know based on, well, let's draw in the different points here first, because I think it'll make more sense. So we know that our focus is at 1, 4, 2, 5. So we're going to go 1 and approximately right here. Let's draw that like this in a darker color. Okay, so this is where our focus is. And we know that our directrix is at 3.75. So 3.75, it's going to roughly be right around here. So here is the directrix, right exactly there. So what we want to do now is just simply based off of knowing where the directrix is and the focus, the distance to the directrix is going to be equal to the distance of our focus. So what we're going to be able to do is, let's just draw some real simple ideas here so that you know how to solve this if you are given the focus and the directrix. Okay, so I'm just going to draw in some rough coordinate planes here, and then throw in some directrix and focus and foci and show you. Okay, so basically, if that is what you have, you are going to have a focus if you have a focus at this point and you have a directrix at this point, what you know is your parabola is going to fall somewhere between the focus and the directrix. Hence, let's say if you had another focus here and a directrix right here, well, again, you know your parabola is going to look like that type of a parabola. Again, if we had, here is the directrix, and here is the focus, where's your parabola going to be? It's going to be like that. So it's going to sort of point between this, and then it's going to form around the focus. Again, put a point here. Let's go and draw in the directrix. Where's the parabola going to be? It's going to be like that. All right? So that tells us everything we need to know about the parabola just by looking at the focus and the directrix. So pretty cool stuff. So what did it say? Given the focus is 1 and 425 and the directrix is 3.75, what was the one? I need to write this in standard form. All right, so let's grab this. The vertex is going to be h and k, and it's going to have the same x value as our focus. So we know that h is going to be equal to 1, and k is going to be equal to the focus for y plus our directrix, and these are just formulas, divided by 2. And this is the distance formula between 2 points. That's what we're using there in this situation. And this is going to end up being equal to 4.25 plus 3.75 divided by 2, which is going to give us a value of 4. So that is equal to 4. So now we know k also. H is equal to 1 and k is going to be equal to 4. So our vertex is going to be equal to h and k, or it's going to be equal to 1 and 4. And we can go and actually plot that in here. So let's go. I need to, well, we're not going to worry about the plotting here in this circumstance. What we want to do is just get this in standard form. Well, then we need to find a value of c to be able to calculate what the a is going to be. And c is going to be equal to the absolute value of the focus y minus the vertex y. And this is going to be equal to 4.25 minus 4, which is equal to 1 over 4. And now a is going to be equal to, or we're going to be able to find a anyway. Maybe I should change the way that looks. So I can say a is going to be found by knowing that c is equal to 4a. And we can continue onwards with this. That means that 1/4 is going to be equal to 1 over 4a. And hence, if we know that a is equal to 1. And then we just plug in the standard form for these values. And we have our information in standard form. So this is going to be y is equal to this. 1 represents the value of a. And then we're going to have x minus 1. The 1 is the value for h. And then 4 is the value for k. And there it is. It is in standard form. All right. Ellipses. Sorry, I have to drink, otherwise I'll lose my voice. Okay, so an ellipse is just going to be a set of points in a plane whose distances from 2 fixed points, which are called foci, have a sum that is going to be equal to a constant. You can see here the standard form for our ellipse. So if we see a formula that looks like this, we can look at it and say, okay, that's an ellipse. And you can see here exactly where all of these different points are based off of finding the values of h, k, and b. All right, so you're gonna, and also a and b, everything is right there and pretty understandable. All right, so in the circumstance in which a is greater than b, then we know that our ellipse is going to be horizontal. And yes, there's a lot of stuff you have to memorize. At the end of this video, I'll post a cheat sheet with all this stuff on it. It's really not that much. I mean, once we get into trig, it's going to get a little bit more overwhelming. So if a is greater than b, then the ellipse is going to be horizontal. And if a is less than b, then the ellipse is going to be vertical. Just something to figure out. So let's see, do I want to graph this? Yeah, I'm going to give you an example here. So what I want to do is I want to graph this formula that we have right here. And how am I going to do it? Well, we know that our center is going to be 2 and 4, based off of what I said previously about the standard form. A is going to be equal to the square root of 9, which is going to be equal to 3, of course. B is going to be equal to the square root of 16, which is going to be equal to 4. And if we want to find our x-intercept, what we can do is the x-intercept is going to be x minus 2 squared over 9. And we just put in a value of 0 for y, of course. So this is going to be 0 minus 4 squared and divided by 16 equal to 1. Let's go and clean that up. That looks like a mess. All right, so this is going to be squared like that. And this is going to ultimately be equal to x minus 2 squared over 9 plus 16 over 16, which is going to be equal to 1. I just subtracted 1 from that. This is going to then give us x squared, like that, is equal to 0. And then we just multiply by 9, and that gives us a value that is equal to x is going to be equal to 2. And so we can go and plot that point. So let's grab it and do it. Okay, so our x-intercept is going to be 2. So we know that we are going to have a point that is right there. And this is just, there's just multiple different ways of figuring this out. So I'm also going to come in and I want to find the y-intercept in this situation. And this is going to be a little bit more complicated. So why don't I go and move this around? I'm going to get rid of this point right here because this is a little bit more complex. And I'll be using a lot of stuff to solve this from the old Learn Algebra tutorial that I did. So you have to understand algebra to be able to do some of this math. So our y-intercept in this situation, again, just plug a value of 0 in for x to figure out where it hits at the different points. So let's get this. That is going to be, I'll put y-intercept is going to be 0. Just put a value in for 0 for x divided by 9 plus y minus 4 squared over 16 is equal to 1. This is going to simplify down to 4 over 9 plus, and then we're going to have to expand this to x squared minus 8y plus 16. And I used just basic FOIL, the FOIL technique, for calculating that. I think anybody that's watched this, if you need me to explain FOIL, I can. The 16 is equal to 1. And then we can go and multiply through this. So what we want to do is we want to find the greatest common factor for both 9 and 16. I'll do like a little bit of a overview. So this is how we find the greatest common factor. So if we have the values of 9 Well, we need to multiply prime numbers together to give us a value of 9. So if we multiply 3 times 3, we get 9. And then we get 16, and we have to break it down into nothing but prime values. So again, you get 2 times what? 2 times 2 times 2. All right, so that if we multiply 2 times 2 times 2, if we multiply 2 times itself 4 times, yes, thank you very much for following. To find the greatest common factor, all we do is take all those values and multiply them times themselves. And our goal here is to get rid of the fraction. That is the whole reason why we're performing these calculations. So the greatest common factor is just simply going to be 3 times 3. I got both of those values from right here. Times 2 times 2 times 2 times 2. And if you multiply all those together, you're going to get a value of 144. So what we need to do is multiply 144 times what we have here before so that we are able to go and get rid of all those fractions. So just to conserve space, what I'm going to do is I'm going to multiply those up here. So I'm going to say 144 times that guy, and then I need to multiply it everywhere. So I'm going to, this is going to become 144. 1 times 144 obviously is equal to 144. And I'm going to grab this, move this over here. And the goal of this video basically is to cover all the trigonometry that you need to make calculus extremely easy. I used to teach calculus to kids, calculus tutor or whatever. And one of the things I did, everybody was always surprised. The first week I showed up, I would have an algebra book. And normally, the second, if they got algebra the first week, which normally didn't happen, soon after I would show up with a trigonometry book, because I'm pretty convinced that if somebody struggles a lot in calculus, that's because they don't understand the algebra or the trigonometry that's required to solve the calculus problems. And I was normally right. Okay, so what we're going to do is just simplify everything here again. Let me just move this out of the way. So this is going to be equal to 16 times 4 plus 9. And yeah, that's going to work. 9, and this will be y squared minus 8y plus 16. I just have to make sure I don't accidentally make any typos. That's why I have to like double and triple check things. And then if we multiply all these values out, we get 64 plus 9y squared minus 8y plus 16 is equal to 144. And then we can go and multiply the 9's through. So this is going to be 64 plus 9y squared, which is going to be, let's just go and get rid of these 144, which is going to come up here next. So this is going to be 64 plus 9y squared minus 72y is going to be equal to 0. This right here cancels out this, so that's the reason why we're able to get rid of that value. And then what we can do is just use our quadratic formula to find the other y-intercepts. So y is going to have two values. It's going to hit two places on our coordinate plane. Whoops, let's get rid of that. Put 72 in there. So this is going to be equal to 72 plus or minus, and let's just leave some space for the square root. So this will be, oh, get rid of that, minus 72 squared minus 4 times 9 times 64, and square root like that. There, got it. And let's take this, and then the value on the bottom is going to be 2 times 9. And this is the quadratic formula that I'm using here. And I think I can get rid of this to give myself some more real estate to figure these all out. So this is going to end up being equal to 72 plus or minus 5,184 minus 2,304, and we'll get the square root of that. And we will divide both of those values by 18, and that means that we're going to have 72 plus or minus the square root of 2,880 divided by 18. And then we can quite simply simplify that down further. So if we want to simplify this, this can be simplified down to 24 and the square root of 5 divided by 18. And so we know that the y-intercepts are then going to be equal to 72 plus approximately 53.66 divided by, these numbers don't always work out perfectly, of course, and this is going to be approximately equal to 6.98. And then if we use the negative version, it's going to be 72 minus 53.6 approximately again, and 18, which is approximately equal to 1.02, I think, or something like that. All right, so the y-intercepts are going to be at 6.98 and also 1.02. And I could go and plot those in and draw that, but I think you get the gist of exactly how that works. So let's cover one more with ellipses. Thank you very much for stopping by, Enlightenment. I greatly appreciate it. All right. So we have a ellipse here in general form, and what I want to do is graph an ellipse in general form. So how would we take x squared plus 9y squared minus 2x minus 8 equal to 0? Well, what I want to do is I want to convert it into its standard form. So this is going to be x squared plus 9y squared minus 2x equal to 8. And then what we can do is factor out the coefficient of squared terms. So if we do this, we'll get x squared minus 2x plus 9y squared, which is going to be equal to 8. And then we need to divide by the coefficient of squares. In this situation, it's going to be equal to 9. So this is going to become 1 over 9, x squared minus 2x plus y squared, which is going to be equal to 8 over 9. And then I need to convert the x to its square form. So this is going to get a little bit more complicated. So this is going to be 1, 9, and x squared minus 2x plus 1 plus y squared. And this will be equal to 8 over 9 plus 1 over 9. And then we need to just simplify from this. So it'll end up being equal to 1 over 9 x minus 1 squared. Again, completing the square like we did previously a couple times is equal to 1. And then we can go and get it back into its standard form. So we'll just be able to go x minus 1 squared over 9 plus y squared over 1, which is equal to 1. And this, of course, can be rewritten as x minus 1 in its standard form, x squared, 3 squared plus, and y minus 0 squared. And it gives us all the data we need to be able to plot out our ellipse. So, knowing all this, what do we know? Well, we know that h and k are going to be at the point of 0 and 1 because of what work we've done previously. And we are also going to be able to know that A is going to be equal to 3 and B is going to be equal to 1 because we know the standard form. Well, where is it? See? There it is. You just have to memorize what that equation is. And if we know that, we can then go in and plot all of our points. So we're going to have a point right here because 0 and 1. And then we know that our B term, this right here, is going to determine how wide our ellipse is. So it's going to be 1. So what are we going to do? We're going to put a point right here, and we're going to put a point right here. And we know that our A term is going to be 3. So 1, 2, 3. Put a point right there. 1, 2, 3. Put a point right there. And then we can draw in our ellipse. And there it is. How to take a pretty complicated type of equation and convert it into a graph. And that leaves us with hyperbolas. And then I'll get into all the trig stuff. Okay. So, basically, a hyperbola is just going to be similar to a parabola, except it's going to have two separate curves, and they are going to be referred to as branches. You can see here the standard form of a hyperbola that is going to open to the left and right. This guy right here. And the standard form whenever it opens up and down is going to be right here. So you have to sort of write these things down to be able to go and have them and understand them. Basically, what happens is the asymptotes are going to be the orange dashed lines, and they're going to pass through H and K and the center, and they will have a slope that is going, the slope is going to be equal to either positive or negative B over A, using that formula. And the transverse axis is going to pass through the center of the branches. So let's go and I'll actually draw this in. Is this the best place to draw it in? Probably. Okay, so, accidentally bounced that off my keyboard. Be back here in a second. There we are. Doesn't change on the screen whenever I accidentally shut the iPad off, which is kind of a little bit weird. So let's go back to this guy and draw on it. So what we have here, let's get some different colors. We are going to basically have points right here. So we're going to have, this is called the transverse axis. So transverse axis. And then we're going to have the conjugate axis. Let's draw that in a different color. So let's grab this guy right here. Maybe, what color should I use? Green, maybe. All right, so we'll have green. So this is going to be roughly right inside of that area right there. And then you can see there's sort of like a box that is going to join these different points together, like that. Okay, and this is called the conjugate axis. So this is the conjugate axis, this guy right here, while the transverse axis is the red axis that lies in the middle. Yeah, thank you for following, Rasmus. Thank you. All right, so that is the different parts. Wow, I'm going to have a whole ton of followers. Everybody uses funny now. Oh, look at that. I got a kitty on my face. Hello, Rasmus. Thank you for following. I'll just move the kitty right there. I think it looks better there. Okay. So what we want to do now is I want to, let's go and get a problem to solve. I want to graph this guy, this formula right here, over onto our coordinate plane. I have to get a drink. Hello, Rasmus. Well, since x is positive, what does that tell us? Well, way back here, we said that if x is positive, that means that our hyperbola is going to open to the left and the right. So, A is going to, we take our formula here and what we know about it. So we're going to say A is going to be equal to the square root of 4, which is equal to 2. And B is going to be equal to the square root of 9, which is going to be equal to 3. Well, based off of that, then we're going to know, based off of these guys right here, we are going to know that our center point, so the center of our hyperbola, is going to be at 6 and -4. Our transverse axis is going to be 2 to the left and right. How do we know that? Right there. And we know that our conjugate axis is going to be 3 and up. Well, how do we know that? Because of that point right there. So what we could do is come in here and actually, you just watched my 3-hour sleep video. Very interesting. Well, feel free to ask questions about it. I'm more than happy to break up this video a little bit and answer questions. Currently I sleep about 4 hours a night, but sometimes 3. So I sleep between 3 to 4 hours per night, and I no longer have to take naps during the day. And for anybody that I uploaded a video, actually originally it was on Twitch, and then I uploaded it to YouTube because a whole bunch of people asked me to. And it's about how in college I trained myself to live with 3 hours of sleep a night. Feel free to ask questions. It's been done and by a lot of people, and I've been doing it for 25 years. I would say probably 4 days out of the week I sleep 3 hours, and then I sort of wake up after sleeping for 3 hours and lay in bed for an extra hour, and then just get up because I can't sleep. And I've been doing it for 25 years, so and I'm still here, and I can run, and I'm not dead. Everybody always tells me, you're going to die. And I'm like, well, I should have died quite some time ago. Okay, so what we're going to do is we're going to plot our point, which is going to be 6 and -4. So 6 and 1, 2, 3, 4. There is our central point. And we know that maybe I should actually label these. Do you think it's possible to start doing it without a nap during the day, right? No. I don't believe it. And everybody that has told, I think you have to do a nap every 3 hours for 30 minutes. I do not believe, because from the beginning, and everybody that I've ever talked to afterwards, first off, they told me if you skip a nap, that is the end. It's called polyphasic sleep is the scientific term for it. They said if you skip a nap, you will fail. And everybody told me that from the beginning. And since then, every single person that I've talked to who tried the polyphasic sleep process and failed, they all told me that they think they failed ultimately because they started skipping naps at the beginning. You can't do that. It's something you have to do. As I showed in the video, it only takes about 2 to 3 days for your body to adjust. Those 2 to 3 days are very bad. But after that, it gets very, very easy. Okay, so our transverse axis, and feel free to ask any questions that you want. I'm happy to break up the video into random different things. So we have our transverse. I'm just going to say trans in this situation. So that's going to have a value of 2, and the conjugate is going to have a value of 3. So we got that all in there. And then we can go and draw that in. And just by looking at this, I'm sort of taking the long way of solving this. Normally, you can just look at it and almost instantly solve it. So what colors do I want to use? There's our center point. I will draw in the conjugate, so 3. So that means the conjugate is going to be 1, 2, 3, and 1, 2, 3. And maybe I'll use a different color in this circumstance. So I can use a different color of blue. This is just going to be 2. So 1, 2, and 1, and 2. All right, so we got that. We got everything else because we can now figure out how to, here's our square that we're going to have. So we can draw our square like this. Okay, so we know this is the square. Just by looking at the thing, you can draw the hyperbola. It's like pretty simplistic. So there is our little box. And we also know that our asymptotes are going to be from the edges of the blocks. So it's going to be like roughly, let's just draw it like this. So it's going to go from this point to that point in the box and just continue. This is just from looking at the graph. That is how easy it is to draw a hyperbola. And all the other ones are pretty easy to draw also. I sort of stretched it out. And sometimes whenever you stretch things out to make it more understandable, I think sometimes you may actually make it seem more complicated than it is. And then based off of that information, well, I know the hyperbola, just from looking at this, is going to roughly, oops, it drew a arrow or a straight line. It's going to look like this. It's going to come down here, it's going to hit this box, and it's going to go like this. And again, it's going to follow down here, hit the box, and go like that. And there's your hyperbola. And that's how easy it is to figure that out. And basically, we're going to have... okay, somebody asked another question. I know that you are always sold 8 hours of sleep a day, but I always keep an open mind. The body needing 8 hours of sleep a day must just be... It's not a fact. It's just quite simply not a fact. I wouldn't be able... I've been doing this for 25 years. Like, if I just did it, 2 weeks ago, I could definitely say that, yeah, maybe I'm doing harm to my body. But I've basically been doing it nonstop for over 25 years, about 27 years, and I'm still here. and I'm active. I run 3 to 4 miles almost every single day of the week. And I'm my brain works, obviously, and it didn't harm me. I guess I can only speak of myself, but it did not harm me. And like I said, I almost always sleep 3 hours. I can't stop doing it. That's the only negative, is I cannot stop. I don't know how to train my body to sleep 8 hours. Like, that sounds insane to me. As insane as it probably sounds to you, that I only sleep 3 hours, it sounds equally, if not more insane to me, that people can sleep 8 and sometimes 10 hours. That just doesn't even sound humanly possible. So it took you just 3 days for your body to adjust. I was thinking how doing this during when I'm supposed to be at. Well, what I did was I started my polyphasic sleep study during winter break. So I wanted to try it. So we had Christmas, and then I immediately came back to school, and I did it on the campus of my school. And so I had 2 weeks where I didn't have to go to school. I did work. I worked during that whole period of time, and that was it. But if it was to take 3 days, yeah, you can't. I worked, but I only worked like 6 hours a day. And you just have to have, if you're working and doing this, you have to have an understandable employer that's going to allow you to take a nap during the day. I have to go get some more water. I'll continue with hyperbolas, and then I promise that I will cover trigonometry here in a minute. Well, I keep accidentally shutting my iPad off. Never had this problem before. All right, I'm back. Yes, I still use Anki a lot. I was learning Japanese for probably a year and a half, and then I kind of stopped doing it because I realized it was impossible for me to talk to anybody in Japan. So that kind of is a problem, isn't it? And that's, I think, really injecting yourself into the world dramatically increases your ability to retain the information. I mean, I knew how to... They're actually Chinese characters. I knew the Chinese equivalent and the Japanese equivalent of writing 4,000 some words or whatever, and all I could do was read. But then I struggled a lot consuming other media outside of reading, because I struggled with understanding because I didn't train myself from the beginning to speak the language and talk. So it's very hard. And so what I ultimately did with Japanese, what was a major step forward, but this was over a year and a half into doing it, was I found a show called Terrace House. And what I would do, it's on Netflix, and I started watching Terrace House, and I would translate the whole entire episode, and I would rewatch Terrace House over and over again until I could watch and listen to an entire episode and completely understand every single thing they were saying. And then I would move on to episode 2, 3, 4, and I think I did this up until about 30 episodes. And so yeah, and that's how I wish somebody would have told me that when I was learning Japanese, that that's one of the best ways to learn it. But of course, you need to learn the grammar, and that's probably what I would recommend to somebody that was starting off with a foreign language, is to understand the grammar of the language, and then immediately immerse themselves into some sort of reality show where they speak that language and converse in a normal way that people do. And I think you'll retain and really get a full breadth of knowledge in regards to exactly what the language is. And for some reason, languages are not taught that way. I don't know why. All right. So thanks. Sorry I chased away a whole bunch of viewers talking about Japanese, but that's all right. Do you think Anki can be useful for learning? Yes. You can learn anything with it. Repetition systems is how I learn absolutely everything. The only thing it doesn't work super well for, you have to have like a developed skill that you developed at youth. And like, for example, I'll give you an example of something I've struggled a lot with learning that is a skill that I did not develop at youth. And that was chess. I've been trying to learn how to teach myself chess through repetition systems. And it because the core skill isn't there, I struggle with it a lot. I have terrible spatial recognition. It's considerably better now. But yeah, if you have a basic understanding of programming languages, you can learn any programming language through spaced repetition. I'm pretty positive about that. All right. So what do we got here? Well, what I want to do is I want to take this guy right here and I want to put it in standard form. And I'm going to have to, and here is the information. I'm going to get rid of some of the stuff here on the screen because this is going to be a little bit complicated. So let's just grab this and delete it. Feel free to ask any questions that you have, whether they're related to this or not. I am more than happy to answer anything. Okay, so we're going to convert this into, whoops, didn't mean to do that. Let's put it into standard form. So what I want to do first is I want to group my like terms, and I want to move them all over to the right. So this is going to become, let's just use blue because I think it's easier to see blue on the screen. This is going to be negative 4x squared minus 24x plus 9y squared minus 72y. And this is going to be equal to negative 72. Then what I need to do is, thank you for following LK37. This is definitely a different type of stream I'm doing here. I want to factor so that my leading coefficient is equal to 1. So this is going to be 4x squared. Whoops, I'm going to put parentheses inside here. 4x squared plus 6x plus 9y squared minus 8y. And I'll have a link to all the notes in the descriptions for these videos. Any reason that you are covering conic? I made a video about it was learn algebra in one video, and I didn't cover conic sections, and I had some people ask me questions about conic sections, so I decided I'll cover conic sections and trigonometry. This is the very last problem I'm going to do with conic sections right now. And if you didn't watch it, of course, it'll be available in the VOD section for on Twitch, and I always eventually upload all these videos also to YouTube. So they'll always be available in multiple different places. Negative 72. And then I need to divide by the coefficient of square terms. So this is going to end up being equal to 4. So this is going to be negative 1, x squared plus 6x, and this will be 9 over 4. Remember, this is what I'm trying to do. I'm trying to convert to one or the other of these guys right here. Yeah, I think a lot of people struggle with math because they don't understand that most of math is memorizing a couple different rules. And once you memorize those rules, you have to memorize them though. Once you memorize them, math becomes a lot easier. But for some reason, math isn't really taught that way. Like, I would just have a great big giant cheat sheet, 3 or 4 pages with all the math rules on them, and then just let students look at those cheat sheets, and then you can do anything. But without that, math can be complicated. If you try to, I don't know, I think people just try to beat into kids' minds exactly how math works, and it doesn't really work that well. All right, so what I need to do now is I'm going to need to divide by the coefficient of square terms. I'm going to get a value of 9 in this situation. So this is going to be negative 1 over 9 x squared. Oops, is that right? Yeah. X squared plus 6x, and this will be plus 1 over 4. See, we're trying to get this into this term format. And y squared minus 8y is going to be equal to negative 2. And I want to complete the square here in this situation. So this is going to be 4 times 6 over 2 squared, which is going to end up being equal to 9. And so we'll say 1/9 x plus 3 squared, and plus 1 over 4 y squared minus 8y. And what you have to do here in this situation is you're going to multiply the 1/9 by 9, and then you're going to add it afterwards. So you'll have negative 2 minus 1. Okay? And then we need to complete the other square, and we're going to go 4 times, this will be 4y, and this will be 8 over 2 squared, which is going to end up being equal to 16. And then this is going to end up being equal to negative 1 over 9. It's just rewriting the same stuff over and over and over again. X plus 3 squared. I'm taking this the long way so that it's more understandable, and I'm explaining all the individual steps. You could, of course, do this a lot quicker. So this is going to be equal to y squared minus 8y plus 16. And this, of course, is minus 2 minus 1 is going to be equal to negative 3. Well, what I need to do is I need to multiply 1/4 by that 16 that I added inside of here. And then that is going to end up, well, let's go and complete the square and also perform that calculation. So that's going to be 1 over 9 x plus 3 squared plus 1 over 4 y minus 4 squared. And if we multiply the 1/4 by 16, we get a value of 4, and that leaves us with 3 plus 4. And then now that we have this, we just put the 9 under the x plus 3 squared and the 4 under the y minus 4 squared. But hard to stay consistent when the number of views get too high. Okay. And yes, there's a repetition can become a little bit harder. In regards to math, I just do one problem after another until it starts to stick. So we just refine this, and we're going to get negative x. Negative is coming from right there. X minus 3 squared over 3 squared plus y minus 4 squared over 2 squared equal to 1. And of course, then we can simplify this down further by taking the value on the right, moving it over to the left, and this is going to become y minus 4 squared over 2 squared minus x plus 3 squared over 3 squared, which is equal to 1. All right, there you go. Thank you for following there. Neck debt. All right. Now we're going to move into trigonometry. After conic sections, trigonometry is going to look really easy. And basically, the study of trigonometry is going to be involving multiple different angles and so forth and so on. So what we have here, I'm just going to label the parts of the triangle. Right here, let's use an orange. This point up here could be known as our vertex. And then this line right here is a side. And then this with a little air, or this is an angle. I'm just going to say it. All right, this is our angle. And the sides in this circumstance would be labeled as AB, BC, and AC, and the vertices would be A, B, and C. And just for some technical jargon, a 1 radian is going to approximately be equal to 57.29 degrees. And you're going to be able to convert a degree into radians by multiplying it by pi over 80, or pi over 180. So let's do an example here. Let's say that I have 90 degrees. How would I convert this into radians? Well, I just multiply it times pi over 180. So that's going to be equal to 90 pi over 180, which is going to be equal to pi over 2. And you can see that that little diagram up there shows you that, yes, indeed, that is true. Okay, so what if you want to convert from radians into degrees? So let's say we have pi over 3 radians. Well, what we're going to do is we are going to take pi over 1. We're going to multiply it times 180 over pi. So let's just multiply this, and this is going to be what this is going to end up in being equal to. Let's just delete that. This is going to end up being equal to 180 pi over 3 pi. And the pi's are going to simplify out, or cancel each other out, and you're going to get a final value of 60. If you want to convert to revolutions, all you need to do is divide by 360 degrees, because the distance around a circle is indeed 360 degrees. Or you would multiply times 1 over 2y for radians. So let's say we had, let's go and delete this stuff, and I will talk about revolutions because it's important also. All right, so, and I'll use blue for this. So let's say that we want to find the number of revolutions of 1,000. All right, all we need to do is divide 1,000 by 360, and that is going to give us approximately, exactly 25 over 9, which is 2 7/9 revolutions. Now, if you wanted to find out how many revolutions you would get with 27 pi over 4, well, you multiply that times 1 over 2 pi, which is equal to 27. Again, the pi's cancel out. 27 over 8. And if you divide 27 by 8, you're going to get 3, which is 24. And 3 and 3 over 8. All right? So that's how many revolutions. Do you use alarm clocks? Wake up every 30 minutes? I used to. I used to use a watch. Thank you for following there, no name. Whenever I was doing polyphasic sleep, I would wear a watch. I had a watch that vibrated and also had an alarm. And that is what I used to wake myself up. This was in the days before I had a cell phone. This was over 27 years ago. I had a cell phone, but it wasn't fancy, and I didn't use anything on the cell phone. I had a watch that woke me up. And what else would we want to cover? I covered the greatest common divisor, and I think that's probably enough. Let's move on to another thing. Okay, so the complement of an angle is that which is going to sum to equal either 90 degrees, so this is going to be 90 degrees, or pi over 2. And so what would be the complement? Let's just say complement of 32. Well, it would be equal to 58 because that's what gives us 90 degrees. And what would be the complement of, let's use a radian in this circumstance, so pi over 6. Well, that would be pi divided by 2 minus pi divided by 6, which is going to be equal to 3 pi, because of course it's the same denominator, minus pi over 6, which is going to be equal to 2 pi over 6, which is pi over 3. And pi over 3 is the same as 60 degrees. What else? Well, our supplement is going to be equal to 180. So 180 degrees. So we take whatever our angle is and we find the value that we add to it to get either 180 degrees and or pi. Okay. So I think you get the gist. We're just going to add values together until we get those different values. I am really going to try this. If I really could get down, it's totally doable. I as I said in the video, the first day is not bad. The first day feels weird. The second and third day feel really terrible. The fourth day is kind of rough, but then afterwards it's pretty much smooth sailing. And I'm talking about polyphasic sleep, if you're wondering. I'll put a link in the description if you want to know what I keep talking about here as we go on. All right, coterminal angles can be found by adding or subtracting 360. Do I have a graph of this? I guess I don't. But if two lines have arrowheads, that's what that's going to symbolize is that they are parallel. So I'm going to just go and draw this in here so that you can see exactly what I mean. So if we have this line like this and this line like this, and we have another line like this, and let's say that this is A and B. Well, to symbolize that they are parallel, we're just going to draw arrowheads on them exactly like that, and we can go and label inside of here different angles on top of that, and let's call this vector C. Well, this is going to be a transversal, and basically that's the whole entire content of it. So basically coterminal angles can be found by adding or subtracting 360 degrees. And let's move on to the standard position. So the standard position, or for a triangle to be in standard position, one side must be on the x-axis, as you can see right here, and the vertex of one angle must be at the origin, which you can see also right here. Draw sort of a dot in there. Hi, no name. Thank you for stopping by and for talking. All right. So this right here, in this circumstance, would be called the terminal. Yes, it's also hypotenuse. This would be our terminal side, and this would be called our initial side. And is there anything else? Basically, the initial side just lies on the x-axis, and the terminal side is the other side of our angle. Let's start getting into some problems here, though. In regards to circles, the radius of a circle, of course, is going to be 1/2 of the diameter, and the circumference is going to be equal to the diameter times pi. And if you wanted to calculate the arc length, you are just going to multiply that times the radius times whatever theta would be in this situation. So this is going to end up, let's choose a new color, 4 times, and I'm going to convert this to radius. This is going to be 3 pi over 4, which is going to be equal to 12 pi over 4, which is going to simplify down to 3 pi. And 3 pi is going to approximately be equal to 9.42. And 135 degrees is, of course, equal to 3 pi over 4. And that is all taken from this slide right here, where I talk about the different angles and how to represent them as degrees and in radians. All right, and I think that would be good. And let's move on. So if we know our arc length is 23.56, this is represented, this is radians right here, by the way, radians. Well, and the radius is going to be equal to 6. What I want to do is to be able to find our angle. How can I do that? Well, in this situation, the theta is going to be equal to the arc length divided by the radius. So we just plug these values in. So we get 23.56 divided by 6, which is approximately equal to 3.92. And let's move on to more. Let's talk about right triangles. I'm just bouncing through and covering sort of the jargon right now. I'll get into the problems here pretty much on the next slide. A right angle is just a triangle with an angle that is 90 degrees. So in this situation, this guy right here is going to be a 90-degree angle. This is called the hypotenuse. And these guys right here, both this one and this guy right here, are referred to as the legs. And let's move on. Let's get into some problem solving. With the Pythagorean theorem, if you have a right triangle, the length of the sides is going to be found if you know all the different sides. So let's just write this out. And that would mean that a squared plus b squared is going to be equal to c squared. And that's also going to work just by, if we go back to our sides, ab squared plus bc squared. Yeah, bc squared is going to be equal to ac squared. And I'll work through some problems here so you can see exactly how that's going to work out. So if we have this little triangle here and we want to find the value for c, what we can do, let's just go like this, is going to be the square root of 7 squared plus 9 squared, which is going to be equal to the square root of 49 plus 81, which is going to be equal to square root of 130, which is approximately going to be equal to 11.4. So that is how we're able to calculate it. How often do I stream? I normally don't stream on Thursday, but I had a doctor's appointment yesterday, so I couldn't stream on Wednesday. I always stream on Tuesday and Wednesday at either 5 p.m. UTC or noon Eastern Standard Time, depending upon where you live. Yes, I'm going to go over all of the formulas, so everything. And also, I'll put a link to the whole entire notes, all the notes that I have here. I'll put a link with all the formulas and everything in the description for this video, and you can get it. It'll be 100% free. I'll put it probably in my Dropbox account or something like that. You'll be able to download it 100% for free. Okay, so we got that 1104. Let's say we have another situation here with this triangle that we have. Again, we're going to solve it in the same way. So let's say we want to find a this time. We're just going to take our sides, and 9 squared minus 4 squared, which is going to be square root of 81 minus 16, which is equal to square root of 65, which is approximately, again, equal to 8.06. And let's go and work with these. This is an example of an isosceles triangle, and it's just any situation in which the legs have an equal length. So if we wanted to find the height of an isosceles triangle, we're going to have h squared, because that's labeled h. I think you can see that, right? Yeah. H squared plus 3 squared is equal to 7. And then we just figure out what it is. So h squared plus 9 is equal to, this is 7 squared. 7 squared. And let's just make this into 49. Just delete that, just to conserve some space. So this is going to be equal to 49. So we know that h is going to be equal to the square root of 40. And we can, if we want to simplify this down, what we can do is figure out the values that we can, or the prime values that we can multiply together to get a value of 40. And those are going to be 2, 2, 2, and 5. And that's how I've covered that even in this video. And so what we'll then be able to simplify out those two terms, and we'll be left with the 2 and the 5. So this is going to simplify down further to 2 and the square root of 10, which is approximately equal to like 6.3 or something like that. Yeah, Tuesday is normally Tuesday, what I normally do is a chess live stream, and I tell random stories about things. That's where the polyphasic sleep thing came from, was actually a chess live stream. So I talk about pretty much anything during the Tuesday stream, and the Wednesday stream is normally about programming or math or machine learning or data science or investing. It's normally very, very similar to that. I am doing calculus. It's very difficult. What was your experience with it? I had a very good teacher in high school who was very stubborn, and but because he was so strict, I had no problem with calculus. I think that almost every person I've ever met that really struggled, especially with intro to calculus, the reason why they struggled was because they didn't 100% understand the algebra and the trig. And that's the reason why I'm covering this right now. I'm going to make a calculus video that'll probably be a multi-part video, but I'll go through just countless. I have a textbook here. I'll show it to you. There it is. If I can get it. There. I'm just going to take this book, which is one of the most popular books on calculus there is. I'm going to work through the whole entire thing. I'll solve every single problem. That's what I'm going to do to teach calculus. And I'll just explain everything. Are you still on the sleeping routine? I don't do the naps, but on an average day, I normally sleep 3, maybe 4 hours. But I do it all in one block. Over time, I transitioned away from the naps into just sleeping 3 to 4 hours at one time with 0 naps. And it took me a while to do that, but that's what I did. And it just because the naps didn't work into my schedule. So basically, by doing the naps, you're able to transition over into sleeping normal, except a lot fewer hours. I had no difficulty for calculus course I had, but real is a different. Yeah. I'll just all I could say is I'm gonna make a calculus course and I'll break it into a bunch of pieces. I'm gonna take one of the most popular books there is on calculus, and I'm just gonna solve every single problem in the book. I think if anybody would watches that would have a pretty good grasp on calculus. I'm gonna do it as a live stream also. Oh, okay. So you're sleeping 4 hours a day. Okay. Well, there you go. I would say about 4 days a week I sleep 3 hours, and the other days I almost always I go to bed at 1 and I wake up at 4. That's what I do almost every single day. All I can say is just keep going at it and really normally anytime I've ever come across somebody that was struggling with mathematics, the real reason why was at some point in time, their knowledge base, there was one thing or multiple things that they didn't quite get. And then it sort of like builds upon itself. And then you don't know what rule to apply in what circumstance to solve different problems because you haven't seen enough problems or you haven't internalized enough problems. And that's normally where struggling with mathematics, it starts. All right. Sorry I have to drink, otherwise I will lose my voice. Okay, so we got that. Well, let's solve this last one. So how are we going to find the value for AB? Again, we're going to do it in the same way. We'll take 6 squared plus 4 squared, which is going to be equal to the square root of 36 plus 16, which is going to be equal to the square root of 52. And this guy is going to be 3 squared plus 4 squared, which is going to be the square root of 25, which is equal to 5. All right, I think that's enough problems with the Pythagorean theorem. I showed a couple different triangles, and I think that should be understandable. And now we're getting into the trig functions. And I think they're pretty easy to remember if you just remember this right here, SOHCAHTOA, all right? You know that, and it's very easy to remember. So, of course, the SO comes from this, the O, H, SOHCAHTOA. Ka comes from here, SOHCAHTOA. And tangent, TOA. So that's where, at least for me, that's how I memorized the different parts. And of course, we are referring to the opposites, the hypotenuse, and we're trying to calculate the value for these angles. And of course, the opposite would be the leg that is the opposite. Yes. Thank you, Rasmus. So the opposite would be the line that is opposite, or the leg or the side that is opposite the angle, and the adjacent would be, this is the hypotenuse, and so the adjacent would be the side of the triangle that is not opposite of the angle. All right, so those are our trig functions. SOHCAHTOA. All right, so now knowing our trig functions, how can we come in here and calculate the angle for this little triangle that we have right here? Well, sine of C in this circumstance would just end up being 4/5. And if we wanted to find the cosine, that's going to end up being equal to 3/5. The tangent is going to be 4. I'm not going to work out this, this division. 4/3. The cotangent is just going to be the reciprocal of the tangent, which means if you just flip the denominator and the numerator, so the cotangent is going to end up being equal to 5/4 in this situation, for C in that situation. The cosecant is going to be the reciprocal of the sine, so this is going to be 5/4. And it's very important to understand. I know this causes a lot of confusion. A lot of people get confused because they're like, well, this is an S right here, so that must line up with this S for secant. No, it's actually the opposite. And so, yeah, those do not line up. The sine is actually the cosecant and not the other way around. So hopefully that doesn't cause you any confusion. Actually, you can just say, well, you would think it would be this, but it's actually the opposite, and it's easier to remember now. I don't know, but that's sort of the way that I memorized it. So 5/3. All right. And another thing is that the tangent of our angle is also going to be equal to the sine divided by the cosine of that angle. So that's another way to work out that solution. Now let's move on to isosceles right triangles. And it's just a right triangle with two legs and also having equal angles. So let's go and just work out a couple little problems. Let's say you have the sine of 90. This is going to end up being equal to 1. And 90 degrees is equal to pi over 2. Just writing this out so that it's a little bit easier to understand. And the sine of pi over 2 likewise is going to end up being equal to 1. And I'll show you graphs of all of these different trig functions so that it is a little bit easier to understand. The inverse sine is going to be written as this right here, or you can also refer to it as the arc sine. And if sine of some angle is equal to 1, then you know that our arc sine, yeah, it's always hard to memorize the formula. That's basically the whole thing. You could use a repetition system like we talked about previously. There's something called Anki, and there's so many repetition systems now. What's the not memorize? What's the other one called? There is, and I bet you they have a whole bunch of calculus formulas in it. Let's see if I can find it. Quizlet is an app that I think is basically free, that's available on all the phone platforms, and you can go and use Quizlet to also plug in the different formulas you're trying to memorize and then write them down as you're working through them. All right, so circumstances in which sine of some angle is equal to 1, then you know that the arc sine of 1 is going to be equal to pi over 2, which is also equal to 90 degrees. Let's see, do I need to do anything else? Yeah, I'm just going to go over a couple different rules here. All triangles that contain 3 angles are going to always sum to 180 degrees. So I'm not going to write that out. Basically, 180 degrees is equal to pi. And all of these guys are going to sum to either 180 degrees or pi in that circumstance. Another thing, AC is going to be equal to, just to cover this again, AB squared plus BC squared, and the square root of that. And if AB is equal to BC, then you're going to let AB and BC be L. And what else can we cover? I think that's the basic jive of this whole entire thing. So now I'm going to move on to unit circles. I'm just sort of trying to get through. Yeah, Anki is probably the main tool I use, and it's I don't know if it is free. I think it's free on Android. It's not free on iPhone. They must hate iPhone users. I don't know. Okay, so this brings us to unit circles, and a unit circle is basically just a circle in the center of a coordinate plane. Yeah, Anki is on the App Store. And it's going to have a radius of 1. Oh, it has fees. Yeah, it still has fees. Yeah, for some reason on Android it does not have fees. I don't know why. So, In this situation with a unit circle, both our angles are going to either be 45 degrees or pi divided by 4, and both the legs are going to be 1 divided by square root of 2 or square root of 2 divided by 2. So let's come in here and let's just label some of these different points here. In this circumstance, pi, or this point, theta, is going to end up being equal to pi over 4, or 45 degrees. Exactly like that. And in this situation, these two sides that we have here are going to end up being equal to square root of 2 over 2. And I think that covers the basics of unit circles. All right, so let's move on to 30, 60, 90 triangles. So let's start doing some actual problems here. Now, if we have all of these values, so we have our 30, 60, 90 triangle here, and we are trying to find a value of h. My notes are a little bit screwy here, so I apologize for that. All right, I'm back. Well, my video on YouTube did really good. I just checked. It had 2,300 views in 2 hours. For me, that's good. For PewDiePie, that's like retirement time, but for me, that's good. Traversy Media actually commented on my video. That's a big deal right there. Wow. I'm surprised. All right, so I guess people do watch my videos. All right, so that's good. All right, just thought I'd let you into my weird YouTube world. Get hydrated. I'm always getting hydrated. There's actually all kinds of weird things in there that you can make me do things using channel points, which are free things. Okay, where was I at? Okay, 30, 60, 90 triangles. Okay, so in this circumstance, with a 30, 60, 90 triangle, what that means is that A is going to be equal to 30 degrees. B, of course, is going to be equal to 90 degrees. And C is going to be equal to 60 degrees. All right? So, what we're then going to be able to do is calculate a lot of other values. So S is going to be equal to 1/2 of H, and F is going to be equal to the square root of 3 times H and divided by 2. So, if H is equal to 6, then that means that S, and I'm using this triangle here as an example, S is going to be equal to 3, and F is going to be equal to the square root of 3 times 6 divided by 2, which is going to be equal to approximately 5.19. All right? Now, if you wanted to find A or the sides AB and AC in this situation, we would take pi over 6 times 180 over pi, which is going to be equal to 180 divided by 6, which is equal to 30 degrees. And AC in this circumstance is just going to be 1/2 times 12, which is equal to 6. And AB is going to be equal to the square root of 3 times 12 divided by 2, which is going to approximately be equal to 10.3. 10.4. All right. And the cosine of 30 degrees is going to be equal to 8.66 in this circumstance. All right, let's move on. Do you sleep 3 hours a day? I sleep 3 hours. This is somebody that probably came over from my YouTube video. I sleep 3 hours a day, 4 days a week, and the other days I normally kind of wake up. I normally sleep 3 hours and then lay in bed for another hour and then get up. So, yeah. I can't sleep. I can't. The positive of polyphasic sleep is that you get an extra 5 hours a day. And I have zero health issues. I run every single day about 3 to 4 miles, and I don't know. I have none. I have zero health problems. Nothing. Nothing's wrong with me. Except I have long COVID, but that has absolutely nothing to do with sleep. Because I did this for 27 years. I've only had long COVID for like a year and a half. All right. So let's move on to unit circles. With a unit circle, the x-coordinate is going to be the cosine of the angle, while sine is going to provide our y. So in this circumstance, if our angle is 30 degrees, or that would be pi over 6, that means that our hypotenuse will be equal to 1. So x is going, if you can remember SOHCAHTOA, TOA, the cosine, ka, adjacent, over hypotenuse. This is going to be equal to the square root of 3 over 2. And so sine is going to be the opposite over the hypotenuse. And that is going to mean that y is going to end up being equal to 1 over 2. And of course, I forgot to write this is x. All right. And basically, if you memorize the square root of 3 over 2 and 1/2 and the square root of 2 over 2, square root of 2 over 2, and 1/2 and square root of 3 over 2, you can find the cosine and the sine of 16 different angles. All right? And so there's some stuff to memorize. That's what mainly a lot of stuff in trig is just memorizing a couple different rules and a couple different formulas and such. Thank you. I'm glad you enjoyed the algebra series. There's a lot of stuff to learn there. Basically what I tried to do was to solve at least one problem in everything that you would ever see with algebra. And that's kind of what I'm doing here. I'm going through all the different parts of trigonometry and show it either explaining all the different rules or solving different problems. All right. So now we move on to reference angles. And they are going to provide the values needed to find another angle's value. So in this circumstance, if we know the hypotenuse is 8 and the adjacent is 6, then we know that h is going to end up being equal to 8 squared plus 6 squared. See, it's the same formulas over and over again. 64 plus 36, which is equal to square root of 100, which is going to give us a value of 10. All right. And the sign for lengths is either going to be positive or negative depending upon our quadrant that we are in. The hypotenuse is always going to be positive, however. And let's see here. What else do we need? So you just need to know about all the different quadrants and such. And let's work through some problems. So let's say we have this angle right here, and we want to find the individual parts here. Well, again, SOHCAHTOA. So we know the leg opposite y divided by the hypotenuse. So this is going to end up being equal to 8 over 10, and these will be positive. So that's going to be 4 over 5. And the arc sine of this, you just flip. So you just get the reciprocal of that, and that will give you that value. The cosine is going to end up being equal to negative 6 over 10, or negative 3 over 5. And the tangent is going to, or SOHCAHTOA. So the tangent is going to end up being the opposite over the adjacent, so plus 8 over 6, or in this, or that'll be negative 6, sorry, negative 4 over 3. And if you're using radians, you just need to add or subtract pi instead of 180 to get similar results. All right. Let's do a little bit more with the reference angles. Now, the different trig functions are going to provide positive angles in different quadrants. And how people normally memorize this is all students take calculus is a pretty simple way to figure out these different quadrants and whether they'll have positive or negative angles. So, let's see, do I have a problem here? All right, so to find y, you're going to subtract 180 or pi from x. And to find w, you're going to subtract s from either 360 degrees or 2 pi. Again, it's just memorizing the differences between the degrees and the radians, which I covered previously. So let's work through an example. So if we have x is equal to 5 pi and you want us, thank you very much, Final Revival. I greatly appreciate that. Really, really cool. Thank you. And you want to find y. How do you do it? Well, you just go and you get your 5 pi over 4 and multiply it times 180 over pi, which gives you 900 divided by 4. And this is going to end up being 225 degrees. All right. And what else would I like to do here? So in that situation, y is going to end up being 225, and we subtract from it the 180, and that is going to give us a final amount of 45. And then if you wanted to convert this into radians, you would multiply it times pi over 180, which is going to give you 45 pi over 180, which is going to be pi over 4. Okay? So there is everything. That is finding those angles and also converting into radians, or converting from degrees into radians, and so forth and so on. So let's say that s is equal to 11 pi, and we want to find w in that situation. Well, we would just take 180 and times 11 in this circumstance over 6. This is going to be equal to 1980, which divided by 6 is going to give us 330. All right, and I think you get the gist of going and then subtracting from 360. Well, I'll do it anyway. 360 minus 330, which is, of course, equal to 30, multiplied times pi over 180, which is going to end up giving us a value of pi over 6. All right, there you go. Work through all of those problems. Let's talk about coterminal angles now. And those are just going to be angles whose terminal sides are the same ray. So let's say that we have our angle x and it's equal to 4 pi over 3. And we have our angle y, which is equal to negative 2 pi over 3. Well, this angle here is going to be 4 pi. That's sloppy. I'm going to erase that and redraw it. 4 pi divided by 3. And we're going to multiply that times 180 over pi. And this is going to become 720 divided by 3, which is 240. And thank you very much for following. I greatly appreciate it. And y, let's draw y inside of here, is going to be 2 pi over 3 times, again, 180 divided by pi, which is 360 divided by 3, which is going to end up being negative 120 degrees. All right? And if you subtract 360 from a coterminal angle, you are going to get the other. So, and if you add 360, you're going to get exactly the same. And let's go and work through this other problem here that is a little bit more complicated, where this angle is way larger. What we want to do is we'll have x be equal to, and we're going to take 17 times 180, and both of these would end up being divided by 6. This is then, of course, if we multiply this out, going to be 30, 60, and divided by 6, which is going to give us 510 for that angle. And for y, in this circumstance, this is going to be 5 times 180, again, divided by 6, which is going to be equal to 900, and divided by 6, which is going to be equal to 150. Am I keeping this all on the screen? Yes, I am. And of course, I think that's roughly everything. All right. So that is coterminal angles. Now we're going to get into what the different functions look like whenever we graph them out, and exactly what happens to them whenever we take these trigonometry functions and either multiply or add them and all those other different things. Now what you're going to find, here is the sine function. Let's go and get this guy instead. You're going to find that over here we're going to have a value of negative 2 pi. And basically, as it says, these graphs are going to repeat in a wave pattern with a maximum height of y equal to 1 and a minimum height of y equal to negative 1. So we can, of course, just change these values into their radian equivalent like that. This point right here where we are touching is going to be negative pi. This is going to be negative pi divided by 2. And this is going, everything just repeats. So pi over 2 up here. And then once again, where it touches, pi. And then down here, we have 3 pi divided by 2. And then 2 pi. Okay? So it just continues onwards and onwards and then onwards. And in regards to the domain, this is sort of a review from the last video. It's just going to be all possible inputs. So domain is going to be basically anything that's a real number. And the range is going to be, remember, so basically a real number. And the range is going to be represented with values that are less than or equal to negative 1, or greater than or equal to negative 1 and less than or equal to 1. So the range is negative 1, less than or equal to, and we can just throw our function inside of here, less than or equal to 1. And the amplitude is going to be the difference between the max and the minimum. So what is that? Well, the max minus the minimum is going, divided by 2, is going to give us a value of 1. And the period is going to be the smallest horizontal distance over which the function doesn't repeat. So that's going to be a period for sine of 2 pi. And there are not going to be any asymptotes involved in this. And as you can see right here, if we go and just multiply negative 1 to our sine function just quite simply flips. And that is how that works across the whole x-axis. And if we're going to make additional changes, so let's say we wanted to add a value to our sine function, that is just going to move it vertically. And if we were going to add and subtract, the constant is going to move horizontally. And again, this is all the different breakdowns of how this is going to work for us. In situations in which we multiply a value, in this circumstance we multiplied 2 times our sine function, that's just going to stretch the graph vertically by 2. And dividing instead is going to compress our function. And if we go and multiply this value inside of our sine function, that is going to compress. And again, dividing is going to stretch. And then that brings us on to cosines and what it's going to do. Now, let's go in and I will mark out all of these different values. So this is going to end up being equal to negative 2 pi. And in this point right here where it hits this line, this is going to be equal to negative 3 pi over 2, and this is going to be equal to negative pi, and this point right here is going to be negative pi divided by 2, and this is going to, well, it's end up at 0, and this is going to be pi over 2, like this, and pi, and as you can see, it just sort of continues onwards from there. In regards to the domain for the cosine function, our domain is going to once again be all real numbers. So there's our real numbers, and our range is going to be represented with -1 less than or equal to this function, or -1 is less than, or the function is going to be greater than or equal to -1, and it is going to be less than or equal to 1. And again, our amplitude is also going to be equal to 1. And there are no asymptotes. And basically, the cosine is equal to this right here. And this is just going to shift our values over to the left. I have a breakdown here of how all of the different changes to the function are going to go and make changes to that function. And like I said, I'm going to put a link in the when the video is done, I'm going to put a link to where you can download all these notes for free. So here's just a rundown of exactly how applying all of these different changes to this function are going to make changes to the function. All right. You can see here a graph of a tangent function. I'm sort of going off the screen here, aren't I? So can I move it down? Oh no, it's still there. That's good enough. All right, so the tangent function isn't going to be defined for all of our real numbers that we have, and its graph is going to contain asymptotes, which are just values that are approached, but of course are never touched. And in regards to what these values actually are, this is going to be, I'm referring to these asymptotes, this is going to be 3 pi divided by 2, and this point right here is going to end up being equal to negative pi, and this will end up being equal to negative pi over 2, and pi over 2, and then 3 pi over 2. Okay? Cool stuff. And of course, I'm sure I said this before, but the tangent of some angle is going to be exactly the same or equal to the sine and divided by the cosine of said angle. And the tangent is going to have a period which is equal to pi. And the domain, if you want to know, the domain is basically all angles that are not equal to whatever, some value k pi divided by 2, where k is odd. And there is our domain and our tangent and all the other stuff. All right, let's go into cotangents. So our cotangent is just going to be a reflection of our tangent. And also, on top of that, since cotangent of some value is going to be equal to the cosine of this divided by the sine. So the asymptotes are going to lie where the sine is 0. That's the reason why we can never reach a point where we can actually plot those points. That's what creates the asymptotes. You can't divide by 0. And that's also the reason why the tangents do not work. Again, the period is going to be equal to pi. And again, we're in a similar way to cotangent, or to the tangent, the domain is going to be all real numbers, basically such that theta is not going to be equal to k times pi, where k is an integer. And that is how we're able to figure that out. Let's move on to secants. Now, basically, a secant is, whoops, let's get rid of that. Secant of x is going to be equal to 1 over the cosine of x. So the asymptotes are going to lie where cosine is 0, or the domain is going to be basically not equal to k over pi divided by 2, where k is odd, just like in our previous example. All right, cosecant. We're almost done with these. The cosecant of x is going to be equal to 1 over the sine of x, and the domain is going to be all real numbers such that our angle is not equal to some value k times pi, where k is an integer. All right, just like previously. And that brings us into trig identities. And what they do is they're going to focus on simplifying trig expressions and verifying the equality of equations. So, and what we mean by cofunctions is a cofunction is going to be the complement of another function. And sine and cosine, tangent and cotangent, and secant and cosecant are going to be cofunctions. And s, if we were referring to this, which I guess I have to move here. Let me just move this out of the way so that we can take a look at this, and then I'll show you how to solve all these different problems. Where do I want to put this? I don't know. I can't put it behind my chair. Am I going to have enough room here to solve this? Let's move it. Oh, can I move it right here? I'm just going to move this right here, and then you can see it. All right. So let's just plug that triangle in here and figure these guys out. So in this circumstance, s is going to be equal to 1/2 h, which is going to be equal to 3, and f is going to end up being equal to square root of 3. Is that legible as a 3? Not really. Let's go and get rid of it. Redraw it. 3. So there is 3 times h divided by 2, which is going to end up being equal to the square root of, 6 times square root of 3 divided by 2. And we know the angles in a triangle are going to add up to 180 degrees because we talked about that previously. And you can see here an example of trig identities that, again, you basically have to memorize because they're going to allow you to take really complicated formulas and manipulate them so that you will be able to further simplify them. So what I'm going to do is I'm actually going to show you some examples where we actually work through all of these. So let's go and let's say that we're going to solve this problem right here using these different rules. Well, what we're going to be able to do is convert this into sine x minus 4 sine x, and this then simplifies down to negative 3 sine x. Is that still on there? Yeah, good enough. With our last problem, again, it looks ridiculously complicated, this guy right here. But if we just apply the simplistic rules, we're going to be able to easily go and take this complicated numerator on top and just convert this into sine of x over sine of x. And this is going to give us a value of 1. See, I took this guy right here and just plugged it in. And you can just convert back and forth. in regards to reciprocal functions, and these are just things you just have to memorize. There's just no easy way around it, but there's not that many, so just, memorize them. All right, in regards to reciprocal functions, again, these just provide us different ways of being able to simplify rather complicated equations down into way more simplistic forms. I'll give you an example. So if we have this little guy right here and we want to simplify it, well, we're going to be able, using these different rules, be able to convert this into the 1 over cosine of x minus 2 secant, which is going to be equal to secant x minus 2 secant x. And, of course, this is going to end up being equal to negative 1 secant x. All right? And we'll move on to the next one. So, again, we're just taking these different formulas and plugging them in to make it easy for us to simplify our overall formulas. So this will be cosine of x divided by the sine of x plus 1 over sine of x, which is going to be equal to the cosine of x plus 1 divided by the sine of x. Simplify this again further. Well, we know from looking at this that this is going to be equivalent to cosine of x times the cosine of x, which is going to be equal to the cosine of x squared. And then something a little bit more complicated here at the end. We can go and convert this complex thing into tangent squared x times the cosecant squared x, which is the sine x squared divided by the cosine squared x times 1 over the sine squared x. And guess what? That simplifies down to just quite simply 1 divided by cosine squared x. All right? Brings us on to negative identities. Okay, so an even function is one in which if we take a function and we can multiply it times a negative of x and they are equal to each other. So an example of this would be cosine x is going to be equal to the cosine of negative x. And let's go and actually show you an example. So I'll do cosine of pi over 4. This is going to be equivalent to basically 0.707. And also, likewise, if you had the cosine of negative pi over 4, guess what? This is going to also give us exactly the same form. I think it's kind of understandable because I was showing the repetition that you see with all of these trigonometric functions, that basically they are going to repeat. And again, the secant, of course, is going to, for the same value, is going to give us a different value, but it is still going to be equivalent values. So this will be pi over 4. Again, that's going to be 1.41. All right, I have to get a drink. Okay, you can see here an example of what it means to be an odd function, meaning that they are origin symmetric, and this rule here would apply. And you can also see examples in which this is indeed true using these different trigonometric functions. I'll solve one of them just to solve it. So if we have sine negative pi over 4, this is going to be equal to 707, and the same is going to be true. I'll just put an equal sign here, negative sine of pi over 4. Okay, so there we go, and that will apply for all of those. Now what we can do is we can take these different rules and apply them again to dramatically simplify our complex formulas. Thank you very much for following. All right, So, how can we do it? Well, we know that this is going to simplify down to cosine of x, and very often whenever you're solving different trigonometric functions and also solving problems in simplifying in calculus, what you just simply want to do is you want to get a certain value in a certain position to be able to solve the problem. That's what all of these different rules do. So, times, and this is going to be equivalent to 1 over the cosine of x, and of course if you multiply those together you get a value of 1. Let's say you wanted to verify that the sine of a negative x times the cotangent of negative x is equal to the cosine of x. How could you do that? Well, we can go negative sine of x times the negative cotangent x is going to be equal to the sine of x times cosine x over sine of x is going to be equal to cosine of x. All right. This last one, or this one right here, is a little bit more complicated. Okay, so let's just move on with this. Verifying cosine of x. So let's say we have cosine x divided by, this will be secant of x. So if we wanted to verify that these indeed were true, what we're going to do is we'll go and get our cosine of x times the negative sine of x times negative cotangent of x. And this will still stay exactly the same. So cosine of x secant of x, and then continue to simplify this. So cosine of x, again using the equivalence. So sine of x times the cosine of x over the sine of x, and equal to cosine x over the secant of x. Again, we can go and multiply these two cosines. So cosine squared x is going to go and simplify down to cosine of x over the secant of x. And because we know that 1 over the secant of x is going to be equal to the cosine of x, well, in that situation, we know that cosine squared x is going to be cosine squared x with this. All right? Boy, moving through. We're almost done. We're getting really, really close to the end. Now it brings us to the concept of Pythagorean identities. Just more rules to memorize. Okay, so we have our rules here, and now what we're going to do is continue to utilize these rules to simplify these somewhat complex problems. Well, we know in this situation that this is going to simplify down to 0 squared plus 1 squared, which is equal to 1. And let's move on to the next one. Well, here, let's go and convert this into 1 plus and sine of pi over 6 divided by cosine pi over 6 squared. I'll put a box around this or something. And this is going to be equivalent, using our formulas, to 1 over cosine of pi over 6 squared. All right. To solve this problem, we're going to use the reciprocal function, and that just says the sine. Let's write that nice. Sine of x is going to be equal to 1 over cosecant x. So this means we can say sine squared x times sine x. And of course, this is going to simplify down to this guy right here. And can I solve this problem in my limited amount of space? I'm going to move this. So I'm going to grab this guy right here. Do I need to? Yeah, why not solve it? Okay, so let's grab this and move it somewhere. Or do I want to grab that other one? Maybe I'll grab this one and move it around. Okay, so this one's going to be a little bit more complicated. So let's just throw it up inside of here and work from here downwards. All right, so this is going to end up being, so we have cosine, simplify this down, cosine x and 1, of course, and minus cosine squared x divided by, let's keep that line straight, sine of x sine x squared minus 1. And what we're utilizing here is negative cosine squared x is going to be equal to the sine squared x minus 1. I think I'm writing that. Yeah, I'm writing that where I get comments. Let's move this down here. So there you are. You can see where that's at. And the sine squared x is equal to 1 minus the cosine squared x. And we're going to be able to further simplify this down to cosine x times sine squared x. And this will be divided by sine of x times negative cosine squared x. And then we can finally simplify that down to its simpler form, which is sine of x divided by negative cosine of x, which finally gives us a value of negative tangent of x. So we can take this extremely complicated thing and convert it into this extremely simplistic thing. Thank you very much, Zen, for fortitude. I greatly appreciate it. Thank you for stopping by. If you have any questions, feel free to ask as I go. I'm getting near the end of this stream, though. Pretty close. Double angle formulas? Actually, I think we are. Well, this is it. Double angle formulas is the last thing that I need to solve. Okay, and double angle formulas are just going to involve trig functions of double angles. And we have here just some different examples, and what I will use, different rules that we can apply to solve rather complicated problems. So let's just go and solve some. So we'll get sine 2x divided by cosine of x. This is going to be simplified down to 2 sine of x cosine of x divided by cosine of x. And, of course, this is going to simplify down to 2 sine of x. And anything else we want to do? I'll do one more problem, and then we're done. I think I've covered pretty much every problem you would possibly come across and almost all the different rules, definitely for calculus, all the knowledge you would need for in regards to utilizing trigonometry rules to solve calculus problems. All right, so let's solve this last one. Well, we know that, oops, I'll do this way. The cotangent is going to be equal to the cosine over the sine. And also we know that the tangent is the sine over the cosine. So, utilizing this information, we're going to convert this into 1/2 of the cosine of x, and, or no, yeah, 1/2 cosine x divided by the sine of x plus 1/2 the sine of x divided by 2 cosine of x, which is going to be equal to cosine squared x plus sine squared x, or sine squared x divided by 2 times sine of x, and multiplied, maybe we want to put parentheses around this, cosine of x, right like that, and continue to further simplify to cosine squared x plus sine squared x divided by sine of 2x, and this is going to further simplify down to 1 over sine 2x, which is equivalent to the cosecant of 2x. Alright, there we go. Solve some rather complicated. Thank you, Zen Fortitude, for the subscription. Greatly appreciate that. That is pretty cool. Oh, my first gift sub in the channel. That is pretty awesome. That's pretty neat. Thank you very much, dude. I greatly appreciate that. Well, there you go. There is a rundown of pretty much every trigonometric problem that you could possibly ever come to, along with graphing and utilizing, and also at the very beginning of the video, I also was able to cover conic sections, which was circles, ellipses, parabolas, and hyperbolas. So that was, thank you, Final Revival. Greatly appreciate it. Pretty soon I'm going to also cover calculus, but I'll probably cover it in a slower sort of format with the different problems and explaining everything along the way to sort of solidify the algebra and trigonometry knowledge that's required at all branches of calculus. I also love calculus. Calculus is where I really started to love math, so pretty neat. Which other math subjects do you use in game programming? Trigonometry you use a lot. In game programming, you use geometry a lot. Those are mainly the core trigonometry, geometry are really the core, and algebra are the core math of doing a lot of games in general. I have a game here. You want me to post my video game tutorial? I actually made a video game tutorial, and it's kind of weird because, let's see, can I do this? Whoops. What, I crash everything? Oh, okay, I'm back. All right, I thought everything crashed for a moment here. Okay, so here, I'll post you a link to my video game tutorial, if I can find it. Let's get rid of that. So let's get rid of this also. Trying to keep everything from breaking. Yesterday I did 2 days ago I did a live stream and it crashed constantly. So I don't want this stream to crash. Where is my video game tutorial? It's on YouTube. And I did it in what I thought was an interesting way. I wanted to make a video tutorial or video game tutorial in which I taught everything in a manner so that the game, I did it in Unity, and the reason I chose Unity was because Unity is what all the indie, like small teams use to develop video games. Like Hollow Knight and, I don't know, I'm trying to think of all the different games. I can't remember all. There's tons of games made in Unity. But I wanted to make it work in Unity, but I also wanted the games to be able to work in anywhere so that the logic could be used for JavaScript, for example. And I made a whole bunch of video games. I made Pac-Man. Here, I'll tell you all the games I made. I wanted to teach how to make video games by actually making games. I made Pac-Man. What was the first one I made? Let me look. I will tell you in a second. Can't remember which one I made. Pong. Oh, I made Pong. That was the very first one I made. And believe me, it gets much better from there. I made Pong, and then I followed up Pong with Space Invaders. Then I made Tetris. Then I made Super Mario. Then I made Pac-Man. And then finally I made Zelda. And then after that I made a video game that was I was tried to make basically the video game Rock Band, or not Rock Band, Guitar Hero in a browser using JavaScript. So here, I'll post a link to it if you want to take a look at it. Everything, I don't sell really anything, so everything is free. There you are. And so I'll copy it and I'll paste it right here. And there it is. Anything else that anybody has any questions about, I will gladly answer your questions. Anything up? Otherwise, I'm probably gonna go. And next week, I don't know what I'm doing but the week after next on Wednesday is whenever I'm gonna start teaching calculus. And for anybody that is here who wants to know what I'm gonna do for calculus, I wanted to get the most commonly used textbook. So I have this one, James Stewart Calculus. Okay? And what I'm going to do is I'm going to go through this book and basically answer all the problems and explain everything step by step. And I'm going to also go, very often in textbooks like that, they just assume that you remember the algebra and you remember the trigonometry and all that. So as I solve all those different problems in that book, I am going to step back and explain, oh yeah, this is an algebra rule and that's why we're able to solve this problem the way that we solve it. But that video is not coming out next week. That's probably going to start coming out the week after next. Thank you very much. I greatly appreciate you, everybody that's in attendance. Of course, I can't see you, so I don't know who you are, but I greatly appreciate you showing up. And this video will be on YouTube next week. I uploaded my video on YouTube about how I only sleep 3 hours a day, and that I'm actually happy to hear it did pretty well. You want to sit there? I'll look live and see how many views it got. I thought it was either going to do well or bomb. And, well, I guess it sort of died off. So we're at 28, 23. So there we go. Maybe YouTube algorithm decided it doesn't like me. But pretty good in my world anyway. So great. Thank you very much for everybody that followed me today. Thank you for the bits and the subs and all that stuff. Why not 4 hours? What's 4 hours? Oh, why not 4 hours? I trained myself to sleep 3 hours, and the problem with doing that is it's almost impossible to go back and be a normal human being after doing that for years. I can sleep, I don't know. It's just what I am. Stuck with it from now on. So, well, thank you everybody for joining me. And I do normally live streams every Tuesday and Wednesday. And 5 p.m. UTC and noon Eastern Standard Time, New York time, whatever you want to call it. All right? So I will catch you next time.